So today we're going over functions. So let's get right to it. The definition of a function. A function is a rule that assigns each input x of the domain to one output f of x of the range. So I think there's a lot to digest here. So let's go over this step by step. So a function is a rule that assigns each input x. So pretty self-explanatory. Input x is going to be any value you can put into the function of the domain. This is another word I should define. The domain is just simply all possible input values you can put into a function. So the domain is just simply all the values you can put into a function. And that could be restricted by the problem. Like for example, say some problem says you can only enter values between 5 or 10. So it's going to be 5 through 10 is the domain of that function. Other restrictions on domain could be by the math itself. For example, you could have some function kind of like 7 over x, and you can't put 0 as x can't equal 0 because you would end up dividing by 0, which is not possible. So the domain can also be restricted in this way. So each input x of the domain is mapped to one output, and I want to emphasize this one here. So each input x is mapped to one output, and we'll also go over that visually, because the other way around it doesn't apply. The outputs can be mapped to multiple inputs. I know it's a little confusing, but we'll go over it visually, and it'll make a lot more sense. So to one output f of x of the range. So if you don't know what this means, f of x simply means the function, f means function, and x is the input that you're going to put into the function. And together, this f of x right here reads the value of the function at x. So it's basically the output. And then finally, I should define range. The range is just all possible output values a function can produce. So to put this one simply, you take all the values in the domain, all the values in the domain, and you put them into that function, and the range is just simply all the possible values that that function can spit out. So let's look at an example of a function. So you would write a function like this, f of x, which is again the value of the function at x, it's the output value, is equal to, let's say, x squared. And let's put into f of x the input value 2, which then evaluates to 2 squared, which is equal to 4. So that's one example of a function. Now let's visually look at this. We'll say you can put the numbers 3, 5, and 7 into the function. And let's say that's all the possible values you can put into the function, which is, again, that's the definition of domain, all possible input values you can put into a function. So this is the domain here. And then let's say the output values you can get are, let's say maybe 8 and 9. So, and let's say these are all the possible output values of the function. So that is the range, all possible output values of a function, all possible output values a function can produce. And then the mapping, let's say, is something like this. So 3 goes to 8. When you put in 5, you get 9 out. And then let's say when you put 7, you also get 9. And that's totally fine. So the one condition on a function is that each input x has to be mapped to one output f of x. So we're good on this side as long as each of these x's only has one arrow going out of it. And it's still totally okay that these two are mapped to the same number because they still each only have one arrow coming out of them. So now let me show you an example of an input-output mapping that's not a function. So let's say in addition to 8, 9, let's say 10 is also part of the range. And let's say that 7 is mapped to both 9 and 10. This is a problem, and this is no longer a function because 7 is now mapped to 2 output values. And that violates this condition of a function, which is that it can only be mapped, each input x can only be mapped to one output y of the range. Okay, great. So now you know the definition of a function, you've seen an example, and we've also gone over a visual representation of what functions are. But why are they important for AI? Again, looking at the example of neural networks, let's draw a very simple neural network here, something like this. And again, at this stage, you don't have to worry at all about knowing really what this means. Just kind of try to listen for this example. So a neural network is essentially going to have some sort of input that you put into this first neuron. And then at the other end, this last neuron is going to spit out some sort of output. And of course, internally, this neuron gives outputs to these two neurons. And this neuron takes that input and spits it out to this last neuron, and this neuron does the same thing. But the point I'm trying to get at here is you can think of a neural network as just kind of one giant function. It's, there's going to be some input here that's going to be processed at a few stages, and there's going to be an output. So the key intuition here is that a neural network is just a huge function. And that, of course, means it follows that rule we just talked about, which is that each input x of the domain is assigned to just one output f of x of the range. So before we finish this lesson, I want to do one quick practice problem. So take a look at these 4 graphs here and identify 2 of them that are not functions. And recall, the definition of a function is a rule that assigns each input x of the domain to one output f of x of the range. So I'll give you a few seconds to think about this, or feel free to pause the video now. Okay, so the answers are both B and D are not functions. And the reason for that is, if you recall, as I've pointed out several times, but just want to make sure it really digs into your memory, a function is a rule that assigns each input x to one output f of x or y. And what that means is, say like when x equals 1, let's say this is x equals 1 here, there should just be one point on that entire vertical line. So like when x equals 1, there should just be one point there. And there is right here. When x equals 2, let's say this is 2, there's just one place, there's just one point on that entire vertical line. And you could see here, let's say when x equals 1 here, you can see that when x equals 1, there's 2 points here. What that means is that 1 is mapped to two y values, which means that this graph is not a function. And similarly here, let's say when x equals 3, there are 2 points here this vertical line intersects with. That means that that means 3 is mapped to two y values, which means that this is also not a function. And what we just talked about here is called the vertical line test. What you can do is whenever you have a graph of a 2D function, so like on an xy plane, you can draw a vertical line through that graph to test if it's a function. If the vertical line only intersects with 1 point for every x on the graph, then it is a graph of a function. More than 1 point, like here, that means that that graph is not a function. And again, the reason that this works is what we really care about is that each input x is mapped to just one y. So what the vertical line test is really doing is checking to make sure that there's just one intersection for every x, which means when that's violated, if there's more than one intersection for any value x, that means that that x value is mapped to more than one y value. So I hope that was helpful. We did repeat a few things again and again, but I just really wanted to make sure that got into your memory.